Hello and welcome back to module number 3. Today's module, I'm going to start focusing more and more about the data aspect of R. In module number 1 and 2, I started to talk about a lot of things that R entails. The functions, the vector, the string, and how to import data to R. But in this module, I'm going to talk about two aspects, the matrix and the data frame that allowed us to import data or to sort the data in order for us to analyze it. In the end, I'm going to talk about the idea of a package, why I'm so obsessed with R, and what is it entail. So, let's start with matrix. In mathematics, it is a collection of numbers arranged into a fixed number of rows and columns. Usually, the numbers are real numbers. In R, is a little bit different because we are talking about a collection of data elements that is arranged in a two-dimensional layout. So in matrix in algebra, we are talking about the idea of M and N. M is the number of rows, N represent the number of columns, and when you multiply the M multiplied by N, we have a matrix. In Solr multiplication, we have a little bit more than that. We have rules and we have theorem that allowed us to sort the matrix out of it. So we have the S and we have the R, and we add the A into what is the value of the matrix in that context by using the following. So it is the layout of the Solr manipulation that allowed us to display it in a matrix format. So the idea here is again the idea of how do we sort the columns and the rows, and in this case we are using this idea of manipulation in order for us to sort that out in order to display it. Okay, so in R, and because R is a mathematical or statistical platform, we have the idea of to display it in two-dimensional, the number of rows and the number of columns. It is used to transform the connected data into matrix into two-dimensionals. So the idea here is that example.array, and I will say organize it based on array 1 to 24, and with dimension of 3, 4, and 2, and that's how it will sort it out in order for me to display it. So this is example of array, and we talked about that in last time. But when we are creating it in R, we are talking about how the matrix row and columns can be displayed or can be generated in order for us to understand the data better. So the idea here is that, and again, I'm using the textbook in page 60, and in our textbook in page 60, we are talking about Y, and we are going to say it's a matrix, and we are going to sort it 1, 2, 3, and 4, and we are going to say it is consist of a row with 2 columns. And so by doing that, we have the content or the context of the data row, and by doing that we can organize it and be more specific when we are going to trying to sort the data based on column number 2 in the lower example. That Y is give me the example of 2, and he will give me the value of that. So the general matrix operation in R. In our textbook, it divided the general matrix operation into three classifications. The first is the linear operation, the second is a matrix index, and the third is matrix filtering. The simple matrix in R, as I showed you before, again, the idea of sorting the data, deciding the number of rows that you want to have, the number of columns you want to have, and sorted it. Actually, we do not need to specify both row and column because one given one R will deduct from the other. But just to make sure that we cover our bases, again, we use to do that just to make sure that we are correct in that assumption. We can use that the data goes by columns by column, unless you specify that the by row equal t, and by doing that you just bypass this stage. A different look, and again using by row equal t, and in this case this is how it will display it. The issue is, again, we can display the matrix in a format of a dim. And so the dim will display the dimension of x in this case, and it will be based on 4 rows and 3 columns. Another aspect of the matrix is the index. So we can use the access element of the matrix using square brackets in the index methods. So the element can be used based on row or columns, but it is possible to use the matrix as an index. So it is a little bit different from the mathematical understanding, but in this case, in the use of the index, the number of columns of the matrix should match the number of dimension of the structure, and as the result will be vector with the length of as the number of rows of the matrix. So the following example, I will try to illustrate the elements of M, and I will show it in the container of 1 and 1, and M in a container of 2 and 2 in one operation. So again, the M is the matrix of 1 to 4 with a 2. So if I will ask what it is, the M, it will display to me in the matrix of 2 columns or 2 rows, and this is the output. But if I will use the I, and then I will use the matrix, and I will say by row, and I will say true, this is how it will display it, and he will bypass the idea of the value of 3 or the value of 4. And again, this is what it will look like in that context. One of the common questions I get with regard to the matrix is, what do we do with the negative values? So in the case of negative numbers or numbers of NA, the value of are allowed for the row in an index matrix contain 0 are ignored, whereas the row container of NA produce NA result. NA, basically you cannot pursue the calculation. So the next stage is the matrix filter. So in that case, we can filter out the data container that we trying to sort based on a matrix. We can sort it out by filtering, and this is a common example. So example, Z and Y. In Z, I have a container that consists of 2, 3, minus 3, and 8. The second container is W, which is the Z multiplied by Z, and it's smaller than A. And if I will say W and the under 1, he will give me the value of it and present the value of it. So in our textbook, provide the following example, and again, this is something that I want you to make sure that you understand. Again, the matrix, I will run the matrix, I will display the matrix, and I can sort the matrix. And in this case, I can sort it not only by allowing me, in this case, it gives me a plus, so I can sort it out. And it might be giving me example of an error. And again, this is part of the issue that we will deal throughout the semester. what do we do with error? How do we overcome? So I'll try to, in the PowerPoint that I will share with you, I will try to come up with a better solution, but I want you to be familiar that you're going to get a lot of errors, and in this case, the symbol of 2, which was not incorrect. So in this case, it did not allow us to do that. Back to our subject, back to the matrix. And in this case, the R matrix in a linear algebra, and we can do that by y multiplied by percentage y multiply. So in this case, again, it is a linear algebra, and this is what it will come up with, again, by applying it. If we will scale it a little bit with 3 multiplied by y, again, this is how it will be allowed us to do that in order for us to apply it. Next is the data frame, and this is the main subject basically of this chapter of module number 3, data frame. And data in R is often stored in data frame because it allowed us to capture multiple types of data. The definition of data frame is a table or two-dimensional array like structure in which each columns contain measurement of one variable and each contain one case. So we can see a case, it's not necessarily the subject or the unit that we are trying to measure. So technically, in R, the data frame is a list of columns that are vector, that there are only one reason why you might need to remember such thing. So unlike array, data that can store in columns of a data can be sorted based on various types. Example, one column, or even more than one columns, or character variables. All columns have to be the same length, contain the same number of items. So the data frame are used to store data, and in this case they are represented as a special type of list where every element of the list has the same length. Unlike matrix, data frame can store different classes of object in each column, just like list. However, data frame also have special attributes called raw names, used to annotate the data. So the data frame are usually created by calling read table or read the name of the file. So you can convert it to a matrix by calling data.matrix with open quotation. So how do we create a data frame? So the df is the identification of the R to the data frame. So in df, and it will say data frame, and we will say giving dimension to it. And so in this case, it will represent the syntax of data frame. Again, this is how we apply to it. Again, the data frame convert matrix to data frame. IS check if the object is a data frame. Dim df is get dimension of the data frame. MTTV is to create a vector from matrix, and we can see how we can apply to it. One of the things that we will see, a lot of packages use the data frame, and this is a good start for us when we are not familiar with the data structure that we are trying to analyze using the R. So how to change a data frame row and columns names. So the data frame has name attributes, which can be used the name of a variable that you can include it into the data frame. In other words, you can set the header of your data frame. As a result, you'll see the names of the variable appear under the data frame. What type of data is acceptable to the data frame? The vector, the matrix, the array. the list and the factor all can be part of this of the data frame. So in this case, it can accept the numeric, the character, the factor, or any other type. And so those are the type of data, and this is how we sort it. So the vector is one dimension, the matrix is two dimension, the array usually consists of two or more dimension, data frame usually consists of two dimensions, table like data collect allow different data types for different columns, and a list is collecting the data object. Each element of a list is a data object. If I was sorted this in a sense of visual, again, the vector, the matrix, the list, the data frame, and the array, this is how the data frame is sorted. It's a block, 3 blocks of data that is sorted to this. So this is my introduction to data frame. We will counter that numerous times. You're going to read the chapter about data frame in this book, and I think I will give you I don't think, but I will give you more materials about that. The second subject that we are going to cover in this case, in this module, is the package. And so one of the things that I need to emphasize again and again is the idea that R is an open platform. Yes, it's great, it's open platform, but where is our contribution to R or the development of R? It is based on the package itself. We are constantly creating new packages that allows any user that has access to it to run it and to apply it into his or her analysis. So the idea here is that you can use any package, download any package, and try to explore, example, converting object to HTML, or trying to do time series analysis, or generate visualization based on it. How to install packages? You have two repositories that are well known. One is the Crane. The Crane is basically under the open source app foundation. This is one of the foundation main objective is to sort those R packages and to be able to have a place that they can be restored and can be downloaded. The other one is Bioconductor, that is also well known. It is usually to the people in biology or computational biology. This is your field, this is your repository. So there is a lot of packages out there, and one of the things that is really the RStudio did quite well with it is the idea of how to install. And when you do it in RStudio, how to install, you name the package and you install it and run on it. So today we talked about basic stuff that I need to cover, that the people who came to my office, and thank you for coming, I thought that I was not able to make sense of what those components of what we are trying to do in this class. So I thought this is the idea of introduction to the framework or the data structure that R is usually consist of. Data frame and matrix, you're going to use it throughout the semester, and we are going to sort it. We talked about vector, we talked about metrics, we talked about arrays, we talked about last time, we talked about lists, and today we talked about data frame. Data frame is, if you will start applying to the ggplot2 how they sort the data, how they organize the data, you will see that the data.frame is the foundation. Last issue that I need to talk, and I felt that some of you did not understand the idea of GitHub, what it is consists of, why is it so important, and so on and so on. I will start the idea of what is it. The idea of GitHub, in compared to any other programming language classes that you took, the GitHub is a repository, which means that you're going to store every module in the class assignment. You're going to store it in your desktop or in your folders in your computer, but also store it in the GitHub inventory. So basically, in 2 years, when you will work in big successful company and you will say, okay, and the boss will come and say to you, you need to convert it into data frame, and you will not remember what is a data frame, the repository will have you as a reference what does it consist. So you need to give a name to each module, and you're going to create a repository. And so in this case, it gives you an outline, quite nice outline of what is it entail and how to do that. And so in this case, we can have a repository. We have, example, files that we store in it. And again, there is a structure that consists of this repository. And so one of the things that I want you to start looking at is what is a master, what is the GitHub, and how we combine that, or how do we synchronize those two files, that one is located in computer and one is located in the GitHub. How do we synchronize when we are starting to work on it? Because one of the things that we like to show is the code that we posted on GitHub, the comments we got in order for us to improve. So this is the introduction. I want you to always commit to the master in order for you to digest or to accept. This is not the actual code that I created. I will start posting more and more examples in GitHub and in my inventory, and I want you to look at that and how to apply it to it. But this is at the beginning, and I hope you will be able to enjoy it and be able to use it as an inventory, not only on your computer, but also on a public repository. This is the module number 3. I hope you enjoy it. If you have any question, please do not hesitate to ask or to email. And until next time, have fun.